Hello everyone, I am Aditya Bansal, a student at IIPS DAVV pursuing my Masters in Technology IT, and in this video we are going to take a look at the 6th semester ADA Test 2 solutions. Our first question is, what is an algorithm? And we can see that we have options: a set of instructions to perform a task, a type of programming language. We know algorithm is not a programming language. A type of hardware component, we know it is not a hardware component. A device used for data storage, no. Algorithm is a set of instructions. When we write the set of instructions, we can perform any task which is computationally possible. So our correct option is A. It is a set of instructions to perform any task. Our second option is, which notation is commonly used to represent the time complexity of an algorithm. Whenever we write an algorithm, it takes a certain amount of time to run, and at the time grows either linearly, or we can say that how worse it can perform, and the worst case, what is the best case, how good it will be. So O of n gives us the worst case time complexity, omega of n gives us the best case time complexity, and the theta of n gives us the average case time complexity. So the correct option will be all of the above. Our third question is, what is the purpose of analyzing the algorithms? Suppose we have three algorithms, each to perform the same task. But now we have to analyze these algorithms. So we will see what the options say. To determine their correctness, yes, we can do that. To optimize their performance, that can also be done. And to make them more readable, no. To make them easier to implement, the main purpose of analyzing algorithm is to optimize their performance. We want to compare these three algorithms, and each algorithm we want to optimize their time complexity, space complexity. The correct option will be to optimize their performance. The fourth question asks us, which of the following is an example of dynamic programming problem? Dynamic programming problem is when we take a sub problem and divide it and then solve it and then build upon it using are subproblems. Among these, first is longest common sequence, the LCS famous problem. Binary search is divide and conquer. Merge sort is also not. Quick sort is also not. The first option, the longest common subsequence, is an example of dynamic programming problem. The fifth question is, which of the following is an example of graph algorithm? Graph algorithms which uses nodes and edges. Binary search is not an example of graph algorithm. Merge sort also does not use nodes and edges. Depth first search does use that, and quick sort does not. So the correct option is C, depth first search, DFS, in which we traverse a tree in depth first manner, and then we traverse each node up to the leaf and then go to the next branch. The sixth question asks us, what is the time complexity of binary search? Whenever we perform binary search, we divide each problem into half according to where it is, if the number lies in the left part or the right part. So the correct is O of n, O of log n, because each is divided into. The seventh question is, what is the time complexity of merge sort? When we perform merge sort, we have a large array of numbers. We first divide them into singular ones and then combine them. So we will have to traverse them and then combine them. It will be O log n. The eighth question asks us, what is the time complexity of quick sort in the worst case? In the worst case, our quick sort algorithm has to go and sort every element, and it is in the, suppose we have to sort the numbers in decreasing order, and they are in already in decreasing order, so it will be O of n square. Ninth is, which of the following is an example of divide and conquer algorithm? DNC algorithm. We will see binary search is a divide and conquer. Depth first search is a graphing algorithm. Huffman coding is also not DNC. Minimum spanning tree is also not DNC. So our binary search algorithm, which divides the problem into half and then finds the solution in that, is a DNC problem. Our 10th question is, what is divide and conquer strategy? As we have talked in binary search, breaking down a problem into smaller subproblems, solving each problem recursively, or it is iterating through a list. We have seen it is not that. Sorting a list elements in the ascending order, no, that's sorting. None of the above. We know that A, it is breaking a problem down in smaller subproblems, solving each subproblem recursively as in binary search. Next, the 11th question asks us, which of the following is an example of greedy algorithm? Greedy algorithms choose the best case possible at any given time, and LCS is not it is a DPP problem. Depth first search is graph problem. Huffman coding is a greedy problem. It chooses the best at any given time. Merge sort is again divide and conquer. So our correct option will be C, Huffman coding. 12th question is, what is the time complexity of Huffman coding? Huffman coding is when we have a sequence or words, and we have which we have characters in it. W. I suppose we have to encode it such that our total size of the document is reduced. So to do that, we need a time complexity of O n log n, as we first divide it, then combine them to assign each character a unique number. Our next question is, which of the following is an example of dynamic programming problem? Binary search is divide and conquer, as we have seen multiple times. Matrix chain multiplication is dynamic programming problem. Quicksort is also DNC. Depth first search is graphic problem. So our correct option will be B. Matrix chain multiplication is a dynamic programming problem, because we dynamically check which will be the best case, and upon that we will divide, and using that we will optimize the complete problem. Our 14th question is, what is the time complexity of breadth first search? It is a graphing algorithm, a graph algorithm, and breadth first search traverses the tree and searches, and so it takes O of n as the time complexity of BFS. 15th question of this test is, which of the following is an example of graph algorithm? We have seen binary search is our divide and conquer. Merge sort is also divide and conquer. Quicksort can also be using divide and conquer. So BFS, as we have seen here, is a graph algorithm. Next is, which of the following notation is commonly used to represent the space complexity of the algorithm? And we can do these, but usually we do O of 1, because most of the algorithms does not take much space, so we usually do, but all of these can also be right. 17th question is, which of the following is an example of divide and conquer algorithm? We have seen that examples of divide and conquer algorithm, and from these ones, this is graphing, this is another DPP problem. So our minimum spanning tree is a divide and conquer. It divides into smaller problems and then combine to optimize the overall problem. Our next question is, what is the time complexity of matrix chain multiplication? And the normal matrix chain multiplication, when we have to multiply any two matrices of n times n times n, it takes n into n multiplications. So our time complexity is O of n cube. The next question is, which of the following is an example of greedy algorithm? Greedy is when we choose the best at any given time. We can solve the minimum spanning tree graphing algorithm using our greedy approach. At each point we will select the edge which has the least weight. And 20th and last question is, what is the time complexity of binary search in worst case? So binary search in the worst case can be log n, because if we have n, it will be divided into n by 2 at each point. So if we have to go through the last, it will be log of n. Thank you. In the set B part of our test 2 of ADA, we have we have to complete the sentences or fill in the blanks. The first question asks us which is the process of finding the solution to a problem step by step. We can find the solution of any problem step by step using iteration. Iteration gives us a solution to a problem by iterating through its elements or processing steps one by one. The second question is the time complexity of an algorithm is denoted by. We can denote a time complexity of any algorithm using big O notation, small o notation, or any of omega, small omega, or our average case theta. But we will stick with our commonly used as big O notation, which is the worst case because our algorithm will never go deteriorate from this. Our third question is which is an example of dynamic programming problem. There are many algorithms. One of them is longest common subsequence problem. So that will be an example of dynamic programming approach. Our fourth question is in the which approach a problem is divided into smaller sub-problems and solved recursively. Where it is asking in which we have to divide the problem and then combine to form a overall solution. That will be a divide and conquer approach. Sorry, the spelling is conquer. And the fifth question is the dash algorithm finds the shortest path between two nodes in a graph. We have to find the shortest path between two nodes in a given graph. So that is done using the Dikshatra's algorithm of finding the shortest path between any two nodes. Sixth question is the dash algorithm is used to traverse a graph in depth first manner. We traverse a graph in DFS manner, depth first manner when we apply DFS, which is depth first search to find an element. Seventh is the dash algorithm is used to traverse a graph in breadth first manner. We traverse a graph in breadth first manner when we apply BFS, which is breadth first search, to find an element in the graph. Eighth question is the time complexity of binary search is. A binary search, we have to find an element in an array. We find the midpoint and then divide it in left and right parts and go to the either left or right part accordingly. So the time complexity is represented by O of log n in the case of breadth first binary search. Ninth question is the time complexity of merge sort is. Merge sort, we have to sort an array of elements. We first divide them and then recursively combine them to form our final array result. This takes our overall complexity, time complexity of O of n log n, as we have to traverse through it, combine it and divide it. So it will be n log n. A 10th question is that is the time complexity of quick sort. In the average case, the quick sort takes O of n log n time by calculating the pivot elements and everything. 10th question is in the dash algorithm, the input sequence is divided into two parts and the search is continued in the part where key may be found. As we have seen, binary search divides the problem and then search where key may be found. So the answer will be binary search algorithm. 11th question of the set B of test 2 is dash is the type of algorithm that always selects the best possible choice at each step. So we have seen in the set A that whenever we have any algorithm and we are solving it, any problem and we are solving it, greedy approach always select the best possible choice at any given time or at each step. So the answer will be greedy. And the next question, 12th, will be dash is a coding technique used to compress data without losing any information. Huffman coding is a coding technique which is used to compress the data without losing any information. It provides each character with a variable size code. such as A can be 0, 0, 1 or B can be 1, as it is more frequently used and it is less frequently used, so our data is compressed and no data is lost. Next question is, dash is an algorithm that finds the minimum weight of spanning tree of a graph. To find the minimum weighting spanning tree, we use the algorithm known as minimum spanning tree algorithm to find the minimum weight spanning tree of any graph. The 14th is, the time complexity of Huffman coding algorithm is. Huffman coding, we have to create a tree and then assign each character a code. So the time complexity is n log n. 15th is, the time complexity of minimum spanning tree algorithm is. So to find the minimum spanning tree of any graph, we have the time complexity of O of V log E, where V is the vertices and edge is the graph. It can also be represented of M log N. 16th is, the time complexity of longest common subsequence problem is. So to find a common longest subsequence problem, our time complexity becomes O of M log of N. Next is the time complexity of, I think I numbered them incorrectly, so it will be 19, 18, so this will be 17. This will be M log N, and for the time complexity of matrix chain multiplication problem, we have O of N cube or O of N cube, because when we have to multiply any n by n two matrices, we have to perform n into n scalar multiplication, which gives us n cube. Next is, the notation used to describe the upper bound of running time algorithm is, what will be the worst case of time complexity. We use the big O notation to specify that. Next question is, the notation used to describe the lower bound of a running time of an algorithm. What will be the best case of any runtime complexity? We specify using omega notation, which is this. Next, we have to match the correct algorithms or the options from both the sides. We can see first is binary search. What will be the correct option? It is a greedy algorithm. No, it is a divide and conquer, B algorithm. Next we have DFS. DFS, as we can see, it is not a DPP problem, it is a E, graphing algorithm, graph algorithm. Third we have, what is the BFS, binary first search. We can also see it is also a graph algorithm, as we have seen it is used to find an element in a graph. Fourth is merge sort. Merge sort, we have to find what type of algorithm it is. It is greedy. No, we can say it is a B, divide and conquer algorithm, as it divides the array in different parts and then combines to form the optimal solution. Fifth, we have quick sort. Quick sort is also divide and conquer. B option is correct, because it finds the pivot element, then divides into left and right parts, which are further solved. So it is also a DNC problem. Sixth is, what type of algorithm is Huffman encoding problem? As we have seen before, it is a compression technique. It is used to compress data without any loss. It is also a greedy algorithm, as it selects at each point the best case, so it can also be greedy. Seventh is what is MST, minimum spanning tree algorithm. It is a graphing algorithm, but that is it is not a graphing algorithm because it is not used to perform any operation on graph. It is solved using greedy algorithm. Next we have what is the upper bound time of running. Upper bound of time is a time complexity. So we can say it is a time complexity. Or if we have the big O, we don't have big O on that side. Ninth is what is LCS problem, how we can solve that. We can solve LCS using DPP, that is option number C. DPP, we can solve LCS problem. 10th is big O notation. Big O notation is a algorithmic notation. In our case, D will be the correct option. The big O is algorithmic notation. It is used to define the worst case scenario of running time algorithm. And thank you. That will be the solutions of second test of ADA 6th semester.